piece of information do I need to know in order to write the correct equation? I have to know the center. What else do I have to know?
Foci.
I don't need to know the foci, actually. I have to know A, I have to know B, and I have to know what other thing? The orientation. So I have to know if it's a vertical ellipse or a horizontal ellipse. So those are the 4 pieces of information I have to know in order to write the correct equation for this ellipse. So I'm going to go ahead and write those here so I don't forget that these are what I have to solve for. Looking at the information that I have in front of me, the center is actually going to be the easiest thing to find first. As I'm looking at the center, I'm comparing the coordinates of my vertices and my co-vertices. What do I notice about the coordinates on my vertices? Say that again. The x's are the same. Those x's, since they are the same, means that the x-coordinate of my center will also match that. So because both of these have a 6 as the x-coordinate, my center will also have 6 as an x-coordinate. What do I notice about my co-vertices? What do they have in common? They're y's. Both of them have a y value of -2. Can you guess what that means for the center of our ellipse? It will also have a y value of -2. So just by looking at the coordinates of my vertices and my co-vertices, I was able to identify the coordinates of my center. By looking at those vertices and co-vertices, I can also go ahead and determine the orientation of my ellipse. I will go ahead and graph it just so you can see graphically what it looks like and how it contributes. However, you can also do it without graphing. If I'm looking for orientation, do I care more about my vertices or my co-vertices? Vertices, because those lie along my major axis, which determines the orientation of my ellipse. So if I were to graph those 2 vertices, I'd go to 6, I'd go down to -8, and I would go up to 4. If these are my vertices, and that's my major axis, is my ellipse horizontal or vertical? Vertical, because this is a vertical major axis. You also could have just determined that because my vertices have the same x, but different y's, so they have to lie on the same vertical line. Questions so far? Everyone okay with how we determine orientation and the center? Okay, now comes the fun part. How do I find the A and the B? Anybody have an idea? I'm going to show you. So to find the A, I know A is always my major axis. So in other words, it's half the distance between my 2 vertices, right? Because this is my major axis, I know its length is 2A. So half of that would just be A. So to find A, I'm going to do 1/2 times the difference between these y values on my major axis. I'm using the y values because the x values are the same. So I'm going to do 4 minus a -8, and then I'll simplify that. 4 minus a -8 becomes +8, which becomes 12, and 1/2 of 12 is 6. So my A value here is 6. Same concept for B, because I know the co-vertices on my minor axis. It's also going to be 1/2 the distance between them. So for my minor axis, the y's are the same, so I'm going to subtract the x's. I'm going to do largest minus smallest. So I'm going to do 9 minus 3. 9 minus 3 is 6. Half of 6 is 3. So my b value here is 3. We always do biggest minus smallest. If not, we would just have to make it positive before we halved it. I have my center, I have A, I have B, and I have the orientation, which means I'm ready to write my equation. This is a vertical ellipse. So which of my x or y values is going to be above the A? Is it going to be x or is it going to be y? If this is a vertical ellipse. Why? How did you know? Somebody said it right. Because of the chart. Also, which axis runs vertically on a graph? The y. So it makes sense if I have a vertical ellipse, then the y will be above my A. So that means I'm using the equation y minus k squared over a squared plus x minus h squared over b squared equals 1. And I'm going to plug in the hk, the a, and the b. We should end up with the equation y plus 2 squared over 36 plus x minus 6 squared over 9 equals 1. Is this coming back to us? Maybe. Anybody confused by how we got that? Yes, ma'am.
For like finding the A and B, how do you know like which numbers to like subtract? Like how do you figure those out?
I based it off the orientation. So we determined that this ellipse was a vertical orientation, which means that my A had to be the distance between my vertices, and my B had to be the distance between my co-vertices. A always goes with vertices, B always goes with co-vertices.
These are like from the chart, right?
Yeah.
Okay, gotcha. Thank you.
Okay, now you're going to do one on your own. So we're going to do the same instructions. So you're going to write the equation associated with the given ellipse. And again, I'm going to give you the vertices and the co-vertices. So this one has vertices of -3, 8 and 9, 8. And co-vertices of 3, 12 and 3, 4. And I would like for you to write the equation for that ellipse. Start us off. If you want? Yeah. I did write all of those over for you on the left as well.
Oh.
I'm going to pause right there. Looking at his center, how many of you agree with it? How many of you halfway agree with it? He has the right numbers, but are they in the correct places? No. How can you tell? Where's the 8 that the vertices share up here? Is it in the X or the Y? So it should be in the Y on the center as well. And then my co-vertices share the X. If you hit the erase and then turn the pen over, you can use the back of it like a normal eraser. And then you have to hit the pen again. Okay, continue. You can move it up if you want to, so you don't have to crouch.
How do you do that?
The arrow on the side. Hit the arrow, like above the pen.
Oh.
And then just roll it up a little. There you go. And then hit the pen again. Show of hands, who else has that equation as your answer? That is correct, at least as far as I can tell. Thank you. Where did we mess up? Somebody volunteer and tell me. Say that again. There's more mess up? No, I mean like where did we mess up out here?
Oh.
Because I didn't see a lot of hands go up, so clearly there's some issues. And I'd love to know where those issues happened. Okay, without graphing, I look at my vertices because I know those lie along my major axis, correct? So they determine my orientation. In my mind, both of these have the same y value, which means it's a horizontal line with different x's. So whatever they have in common kind of tells me which axis it runs perpendicular to. So since they had 8s, which were the y's in common, my major axis had to be perpendicular to the y-axis, which would make it a horizontal line. I would say the easiest way would be at least to graph the two vertices, but that's how you can do that. Where else did we mess up? Yes, ma'am.
Finding the A.
The A and the B. Okay.
Finding which numbers to put. Find.
Okay, so
the points.
How did you do it then?
I not.
Okay,
I
you just
see
didn't
the-
know where to.
Yeah.
Okay, so we always go to, for A, we go to the vertices. I just look to see what's different. Here, the 9 and the -3 were different, so I did bigger minus smaller. For co-vertices, which were my B's, I looked to see what was different, and that's what I subtracted. So I did the 12 minus 4.
Okay.
It wouldn't make very much sense if I did 8 minus 8, because that would be 0, so I have to do what's different. That's a really good question to have, though. Where else did we find confusion or mess up? This is a learning experience, so I'd love to know where we had issues at. Nobody? How many of you feel confident that if I gave you another one of these, you could do it? Okay. Those of you who don't feel confident, why don't you feel confident?
Because I feel like I might switch up a little step
Okay.
on accident.
That's really common, but if you do and you messed it up one time, you know not to do it again, or you'll remember not to do it again, right? This is still new. I fully expect there to be issues, and if you don't feel confident, that's perfectly fine. But I would like to know what would maybe help you be more confident other than doing some more examples, because of course we're going to do that. Okay, so I'm going to temporarily give you a break from this type of problem, because I want you guys to just let your minds kind of think about it. And I'm going to show you another type of problem that I did pose on your homework. And then we'll come back to this one if we have time at the end, or one like this one, okay? So the next type I'm going to do is I'm going to give you an equation for an ellipse, but it's not in standard form. And we're going to have to manipulate it to turn it into the standard form equation that I can pull information from. Because if it's not like this, I can't pull any information out of it. This is going to be very similar to the double completing the square from the circles notes. It'll be so much fun. Okay, so we want to write the standard form equation. For the ellipse, 25x squared plus 9y squared plus 250x minus 36y plus 436 equals 0. We're going to start by simply putting this in standard form, and then we will pull some information out of it. Think back to double completing the square for the circles homework. What was the first thing that we had to do when we were completing the square there? Move the constant over. I cannot have it connected to any variable. So here my constant is that positive 436. When I move it over, it's going to become a negative 436. At the same time, I should probably go ahead and do what? Perfect. Reorder it so my x's are together and my y's are together. So when I do all of that, I get 25x squared plus 250x plus 9y squared minus 36y equals negative 436. So I reordered to put like variables together, and I moved the constant to the other side. This is where it gets a little bit different than it did for these circles. Okay? What do I notice about both my x squared and my y squared here? Are they by themselves, or do they have something attached to them? Which one is it? They have something attached. So what I need to do is I actually need to separate that number from in front of my x squared. When I separate it from the x squared, I'm also simultaneously dividing it out of the x term. Same thing goes for the y squared and the y. When I take the value out of the y squared, I'm also dividing it from the y. And we're just going to leave it in front of their respective variables. So when I separate this, I'm going to divide a 25 out of both of these terms. And it's going to become 25 times the quantity, x squared plus 10x. And I'm going to leave space because I know that I'm going to have to put a third number in there. We're going to do the same thing for the y's. I'm going to take a 9 out. What I'm left with then is y squared minus 4y. Again, leaving space for a third number. And then still equals negative 436. So I factored out that number because it's going to have to stay there. That number will stay there for the duration of our process here. I mentioned that I know I have to put a third number into each of these parentheses. Do I have any idea about how to find that third number? Yeah, we're gonna do that C thing. So the number I'm gonna put in with the X's, I'm gonna label as C1. The number I'm gonna put in with the Y's, I'm gonna label as C2. And what I do to one side, I also have to do to the other, with one catch. Because C1 went into a parentheses with an undistributed 25, that 25 is now attached to the C1 and has to be left with it when added over to the other side. The same thing applies for the C2. It has a 9 attached to it, so that 9 has to be added over with the C2 on the right-hand side. So to keep this in balance, whatever value I factored out gets added in when multiplied with our constant C1 and C2. Does that kind of make sense? Or do we see how we did that? Now comes the super fun part. How do I find C1 and C2? What do I use from this set of numbers? It's gonna make me a little sad. We use the number that came in front of it, split it in half, and square our answer. So C1 is going to be 10 divided by 2 and then squared. What's 10 divided by 2? 5, and what's 5 squared? So C1 is actually 25. And I'm going to write it as such on both sides of the equal sign. So what I have now is 25 times x squared plus 10x plus 25 plus, over here, this C1 becomes a 25, and it's going to get multiplied by the 25 that followed it over. I'm going to do the same thing with the C2, except instead of 10, what number will I be using? The -4. What's half of -4? What's -2 squared? 4. So that C2 is going to become a 4. And it's also going to become a 4 over here on the right-hand side. Again, it's being multiplied into the number that followed it over. So then this equals 436 plus 25 times 25 plus 9 times 4. And then all we have to do is simplify the right-hand side, factor the left-hand side, and then we only have one step left to go. So I know, because I created it to be so, that each of the factors on the left-hand side are a perfect square trinomial, which means they're going to factor into the same number twice. So what number times itself equals 25 and added to itself equals 10? 5. So this factors into x plus 5 squared. Same thing with the y's. I'm looking for a number times itself that equals 4, and when added to itself equals -4. What do we come up with? -2. So it's going to be y minus 2 squared. And it's going to be equal to all of these things added together, which I believe equals 225. And I'm going to pause right here, just for a minute. Yeah, because that's a -436. And I'll add to it the 25 times 25 and the 36. I just don't know. It's 625. Let me look at why I did that. Is everyone okay up to this point? I know it's a lot of work. I know it seems really, really confusing. And honestly, at this rate, we're probably going to stretch this lesson into one more day. Just because I don't want to rush this for you guys. Because then it could turn really bad and I want to be able to answer all your questions. So is everybody okay or able to follow it up to this point? Is this the standard form equation for an ellipse? No. First of all, there's no fractions happening. Okay, and I know that my A and my B are not both 1 because that would make it a circle. But what is this equal to on the right-hand side? What number is that? Not 1. And I know every ellipse equation has to be set equal to 1, which means to turn this into that standard form equation, I'm going to have to divide this number out of all 3 of my terms. So when I divide it out, I'm going to have 25 times x plus 5 squared over 225 plus 9 times y minus 2 squared over 225 equals 225 divided by 225, which equals 1. And then I just get to reduce the numbers on the top and the bottom. And I can use a calculator for that. So 225, when I divide 25 out of it, leaves me with 9. So this reduces to x plus 5 squared over 9 plus 225 divided by 9 becomes 25. So that's my new denominator with y minus 2 squared in the top, and it is set equal to 1. That is the standard form equation for this ellipse. Everybody okay up to that point? Or able to follow it to that point? All of your faces look so sad. Okay, so before we jump into another one, we're going to go ahead and pull information out of the standard form equation, such as the center of my ellipse, the length of my major axis, the length of my minor axis, and then the coordinates of my foci. Okay, so those are the 4 things that I would like to solve for here, as well as the orientation, but that's a really easy one. So let's go ahead and start with orientation and center. What is the orientation for this ellipse? Is it horizontal or is it vertical? Horizontal. Why do you say that? How do we know it's going that way? I haven't graphed it yet. Okay, A is always my biggest number, right? Which one of these 2 numbers is bigger? The 9 or the 25? Which one? Not a trick question. 25, which means this is my A, and what coordinate is above my A? Y, which means this is a vertical ellipse.
Why is it over there? I thought A had to go first.
It doesn't have to, it's just how we typically write it. But we didn't write this one, we created it from something that was already there. So it's always whichever number has the largest denominator, whatever coordinate that is, tells us the orientation of our ellipse. Everybody okay with that? Xavier, what's the center of my ellipse? Kind of flip them around, and then I didn't like the 5. Flip them around. Is it 5 or is it negative 5? Okay, it's always whatever is grouped in with the x with the opposite sign, so it's going to be negative 5. And then whatever is grouped in with my y with the opposite sign, just like it was for circles. So the center here is negative 5 too. The last 3 pieces that I want are the length of the major axis, the length of the minor axis, and then the coordinates of the foci. It's going to be easier to do the major and the minor first and save the foci for last. So looking back at the notes where we wrote everything out, what is the length of my major axis equal to? Just in general, what is it equal to? Look back at the notes, we actually wrote it. I heard somebody say it. 2a. So in order to find the length of my major axis, I first have to know what a is. A is going to be the square root of the bigger denominator. So my a value here is going to be the square root of 25. I know I'm only dealing with positive values, which means a equals 5. And if a equals 5, then the length of my major axis equals 2 times 5, which is 10. It's going to be the same process to find the length of the minor axis, because I know the length of the minor axis is equal to what? 2b. B here is going to be the square root of the smaller of the denominators. 9 is my smaller denominator. Square root of 9 is 3. So the length of my minor axis is going to be 2 times that b value of 3, which equals 6. Everyone okay on those 4? Do we see where they came from? The last piece are the foci. So the really good news is all I have to do is find C, and then I'm going to add that and subtract it from one of the coordinates of my center, and then that's the foci. It's really easy to find once we know what C is. But how do I find C? Close. There you go. We have an equation that says c squared equals a squared minus b squared. So I'm going to use that because I know what a and b are. In fact, I know what a squared and b squared are, but that's okay. So c squared here is going to equal my a value of 5 squared, which is 25, minus my b value of 3 squared, which is 9. What's 25 minus 9? 16. So c squared equals 16. But I don't want c squared, I want c. So I square root both sides, and I get that c is equal to 4. So now the big question is, am I adding and subtracting 4 from the x-coordinate of my center or from the y-coordinate of my center? Go back and look in the table because we wrote it out. This is a vertical ellipse. So for 4 vertical ellipses, do I add and subtract the c from the h or from the k? K. All right, we're all okay with that? So that means that the coordinates of my foci are going to be my center with 4 added to and subtracted from the y of my center. And then I just simplify it out. So 2 plus 4 makes 6. 2 minus 4 makes negative 2. So these are the coordinates of my foci. Yes, ma'am.
Okay, so what if your C doesn't collapse? Like,
Then you're going to take it to 2 decimal places and still add and subtract it. Yeah. That is a wonderful question. How do we feel about this? Awful, just the worst. You guys really do look so down today. Before we end, because we don't really have enough time to do another example, I will ask you to self-evaluate how you are feeling. So I would like to do a 1 to 5. So this is all together. So with what we did yesterday and what we've done today, I would like to know how you're feeling with this. So 1 to 5.
It's to the lesson.
Uh-huh. Okay. So we are gonna go ahead and break here. I expected to see a lot of 3s. That's not a bad average for this kind of information. So I'm still pretty happy with it. Tomorrow we will stretch this into a 3-day lesson to give you guys more practice time and more time to process everything that's happening. I do expect that you're gonna take the remainder of class though to work on the homework. Say that again.
I need that.
Oh yeah, of course, honey. There you go. You're welcome.